In section 1.6, starting on page 41, we start to talk about linear inequalities. So when I'm talking about linear, that means we are going to be dealing with lines, and inequalities means that they are not going to be equal. So instead, we are going to see these four symbols. So we have greater than or equal to, less than, and less than or equal to. And we most certainly will see some numbers and some x's and y's as well. So you may see something that looks like x is greater than 5, and you need to be able to plot that on a number line. So we want a couple of numbers on there that are nice and evenly spaced. So let's say that's 3, 4, 5, and 6. If it is greater than, it is going to be an open circle. So it's not equal to, so it's not exactly on 5, but since it's greater than 5, I want to color in that line in that area to show that it could be 6, it could be 7, it could be 8, it could be 9, right? It will be shooting off to the right. If it was greater than or equal to, that means our dot is going to be filled in. It will be a closed circle. And it would be the exact opposite if I have x is less than 3. So I may have 0, 1, 2, 3, 4. Alright, open circle, and since it's less than, it's going to cover all of these numbers shooting off to the left. Alright, let's look at a couple more complicated examples. Here's an example of what is called a compound inequality. Alright, it's compound because it has two different pieces. So not only is x going to be greater than or equal to -3, but x is also going to be less than 1. So here's how I graph that. A compound means it could be have and be put together, or it has the word and, or it could have or. So it could be one or the either. So for this one, I want to go at least from -3, so let's go -4, -3, -2, -1, 0, 1, 2. Alright, that should work. They're nice and evenly spaced. And x is greater than 3, so I'm going to do just a little bit of a sketch up top. Alright, x is greater than or equal to, so that's going to be a solid circle. And it's greater than or equal to -3. And x is less than 1, so that's what x is less than 1 looks like. So since it says and, that means that it has to meet both requirements. So it has to be the overlap of those pieces. So it's going to be from 3, which you can see x falls between -3 and 1. However, it's going to be an open circle at 1 because it's not included on this line right here, and it is included, but it has to be what they have in common, and they do not have that point in common. So that is the graph in which we want. We also want to graph an or compound, so let's do that. Alright, here's an example of a compound inequality that has or instead of and. So we're not looking at the overlap and what they have in common, but we are going to be including everything. So x is less than or equal to -2, so that's going to be a solid point here on -2, and it's less than. Or x is greater than 1, alright, so open circle at 1. Since it could be on this line or this line, I need to keep my options open and plot both of those parts. So it's going to look like this. Alright, I do suggest that you sketch it above and then draw your final answer below. Alright, I'm going to work through a couple more examples real quick. Alright, for this one, or, that means I want to include as much as I can. Here is x is greater than 1. Alright, so we're going to cover 2. 2 is greater than 1. And x is greater than -1. Since they are both included, on the x is greater than -1, my final answer, alright, if it's greater than 1, it's definitely going to be greater than -1. So since it could be on either one of them, since it's or, I'm just going to go ahead and graph the x is greater than -1. Alright, and in class we're going to continue with this concept, however we're just going to make it a little bit more complicated and look at examples like this that have multiple parts that might have a negative next to an x. What do we do? So we'll explore that during our next class period.